example 1.72. I know that there's solutions for all these examples, but I want to talk through it because I think this is a pretty in-depth example. Maybe it'll help to have another medium of having the answer explained to you. So I have this function, f of x equals the absolute value of 4x plus 1 minus 7. If you have this function, you can think back to function transformations and graph it. And in fact, your book did exactly that. Maybe we can quickly verify that this is the right graph. This 4 right here, well, I have two horizontal transformations, this 4 and this plus 1. And I have one vertical transformation, this negative 7. So I'll worry about my horizontal transformations first. With my horizontal transformations, I apply the plus 1 first. And what the plus 1 does is I subtract positive 1 from each of my x values. So the vertex used to be here. It moves over to here. And then what I do is I apply this 4. And what I do with this 4 is I divide all of my x values by this 4. So this point, who has an x coordinate of negative 1, if I divide it by 4, it goes to negative 0.25. It ends up right here. And then finally, my horizontal transformation of minus 7, I would shift this thing down by 7, and it would end up right here. I haven't verified the entire graph. I've just verified that the vertex ends up right here. But if you did that for one other point, maybe that would be enough to convince you that this is in fact the right graph. If you started out with the graph of the original absolute value function, which would look kind of funny because the axes are so screwed up here. 1 is way the hell over here in the x direction, but 1's right here in the y direction. But the untransformed graph, I guess, would look something like this. And you could pick a few points on that graph and translate the points, and you'd see that they'd fall right on this graph. And once you have the graph, solving the equations are relatively easy, although I don't think this problem is going for this graphical approach, although it does kind of verify the result that way. We want to find the x values so that f of x equals 0. This is saying figure out what you put into your machine to make 0 come out. Well, 0 coming out of the machine means the height is 0. The height is 0 right here and right here. So if I put in 1.5 as my x coordinate, 0 would come out. And if I put in negative 2 as my x coordinate, my input, 0 would come out. So my solution should be negative 2 and 1.5. And sure enough, that's what your book got when they solved this thing algebraically. I'm going to go ahead and solve this algebraically, really going through the exact same steps your book did, just because for me it helps to have somebody talk through problems. So I want to figure out when f of x equals 0. Here is f of x right here, the absolute value of 4x plus 1 minus 7. So I want to know when that equals 0, so let's set it equal to 0 and solve. This would be easy to solve if there weren't the absolute value symbols in there. Unfortunately, there are. So what you're going to do, you're going to get rid of the absolute value symbols. I like to isolate the absolute value symbols before I get rid of them. So the way I do that is add 7 to both sides of the equation. Now this absolute value symbol is isolated. A lot of people at this step just memorize what you do next. I like to talk through why it works. I'll leave it up to you how much you want to memorize and how much you want to understand. What I'm saying is that the absolute value of this unknown thing right here equals 7. So from there, I can figure out what this unknown thing is. This 4x plus 1, I can figure out what it is. Either this thing equals 7, because then when I take the absolute value, I get exactly 7. Or perhaps this thing inside the absolute value symbols equals negative 7. Because if this equals negative 7, the absolute value of negative 7 would be 7. So you're not so much taking this equation and kind of doing anything to it. You're thinking about this equation and specifically what must be inside the absolute value symbols to make this thing true. What a lot of people do is they just memorize, you drop the absolute value symbols and you throw kind of a plus or minus in here. It's fine if you want to memorize it. That's why it works. From here I have two equations, so I'll just solve these two equations. Solve them by getting the x all by itself. So over here I'd subtract 1 from both sides of the equation. And then I divide both sides by 4, and 6/4 is the same as 3/2. So I'd come up with 3/2 as my solution. And over here I subtract 1 from both sides of the equation and divide by 4 and get negative 2 as a solution. If you just memorize this step with the plus or minus, it might not be a bad idea to check these answers right here, because had this been a negative number here, your solutions wouldn't work. But if you talk through it and think about why things work the way I described it, you don't even need to check your answers. Or I guess you can look up here and verify that, well, the book's getting the same answers that I am. That's a good sign. So I guess I'll call those the solutions and end this here.